Howdy folks, Mr. Reed here, and welcome to one more question. It's been a little while since I made my last video, so I might be a little bit on the rusty side. Just happened to be the way that school was ebbing and flowing, and so wish me luck for this one. So, what I'm going to be taking a look at right now is that for long division, we can do it actually with polynomials, and so I'm going to just take a polynomial long division question and just do it out in full and explain it as I go through it, as well as I'm going to take one that has a little bit of a, not a problem, but something you may not always be on the lookout for, but you really should be. So if you want to see a polynomial long division, you're in the right place. Let's get to it. Okay, so what I have written up above is I'm going to take the expression 3x to the fourth power plus 4x to the second power minus x plus 2, and I'm going to divide that entire expression by x minus 2. So the way that I'm going to attempt to do this is by approaching the problem as a polynomial long division. So my divisor is going to be x minus 2, and my dividend, although nobody ever calls it that, is the 3x to the 4. Now, before I actually put in the plus 4x squared, one of the things that happens is that because this is a linear divisor, it naturally stair steps, I guess you could say, your orders down by 1 every time. So we're going to find a cubic part of the quotient first, and then we're going to completely eliminate the part of our dividend that is in order 4. And what's going to happen is that the constant part of the linear divisor is going to multiply as well by that cubic part of our quotient, and it's going to create a cubic piece. And so if I naturally have a spot for that cubic piece to go, it's pretty easy to keep organized. One of the downfalls that can happen when doing these questions is that you get this nice tidy polynomial like the one that we have right here, but it has a 0 coefficient on one of the terms. So in this case it's 0x cubed. So because of that, if I don't write down 0x cubed here, it's not that it will make the problem more difficult, it's just that it's harder for me to keep organized. You might find it that way too. So I highly recommend to people that they actually place a 0x cubed in as kind of like a placeholder, just so things naturally step down in a way where when you subtract, you don't have to be quite as accident prone, I guess, as you could be if you are to miss that there actually is a term that has 0 of something. So let's keep going. I'm going to write down the rest of that polynomial. So it's plus 4x squared minus x plus 2. Extend my little long division symbol there a little bit further. And now we're going to start the process. So what we're doing is we're actually going to take the first part of our linear divisor, and we're going to concentrate on just making sure that goes in evenly. Because what will happen is if that goes in evenly, as I had just been talking about with the stair step idea, it's going to create exactly the correct amount of x to the fourth powers, which we'll then subtract away because we've taken care of those pieces, and then the leftovers will be cubic or lower. And so that's good because when we take that cubic and multiply it by the constant part, we're going to find out that even though we said it went in evenly, it really only went in evenly for the fourth power piece, but not for the cubic piece. But that's okay because we already have some other cubic stuff that we'll have to put into it. So let's actually do that and show what I mean. So in this case, it's entirely up to you where you want to put the what's going to go into the quotient. You could line it up so it lines up with the cubes. You could go all the way and put it right over at the first spot, which is with the fourth powers. I think I'm going to line it up with my cubes this time. So in this case, we get 3x cubed. Now the reason why I'm getting 3x cubed is because when I multiply that 3x cubed by the x that's part of my linear divisor, I'm going to get exactly this term here, which is 3x to the 4. So that will completely be taken care of, and then I'll just have to see what other pieces I can mix in there to make this go in as evenly as I can. I also made this polynomial totally randomly, so the odds are that it divides in evenly is pretty low. Could happen, but I highly doubt it. So we're going to get as our leftover bit 3x to the 3 times this x gives us 3x to the 4. And then we're also going to have, though, the 3x to the 3 times the negative 2 as our other bit, which will give us negative 6x cubed. Now, we have already basically said that if we were to multiply this back out, this is what would be created. Now, the thing with that being created is that we actually don't need all of those negative 6x cubes. So we have this extra amount right now of 6x cubed that we need to be able to basically get rid of. So we're going to continue doing that. Depending on what you like to think of when you continue doing your long division, I'm going to bring down this next piece, which is 4x squared. And again, I'm going to focus on just having the linear x part of this go into 6x cubed. So again, it's going to go in positive 6x squared times. So when I do that, I'm going to take my positive 6x squared, multiply it by the x, and it will give us 6x cubed. And not by chance, that's because we chose it to do that. But I'm also going to get minus 6x squared times, it's positive 6x squared times negative 2, which gives me negative 12x squareds. That is going to be the part that I'm going to take away from what I already have. So I get 6x cubed minus 6x cubed, which, again, by no surprise, is going to give me 0 because we selected it to go in evenly. But we get 4x squared minus a negative 12x squared, which gives us 16x squareds. I'm going to pull down my next term that I'm dealing with up in the dividend part. So minus x comes down, and then we are going to start that process all over again. So I'm going to take my x and put it into 16x squared. That goes in 16x times, which leaves us with 16x squared. Multiply this by my negative 2 as well, which gives me negative 32x. Going to do that subtraction and get 16x squared minus 16x squared is going to give me 0 again. Negative x minus a negative 32, adding 32, is going to give us 31x. I'm going to bring down my 2, and then I have the last part of my division. So the last part of the division here is going to be how many times does x specifically go into 31x? Well, that goes in 31 times. So that's going to leave me with 31x minus 62. I'm going to do this subtraction one last time, and I'll get 2 plus 62 gives me 64. Now, that means it didn't go in evenly because we have a remainder. The neat thing about long division remainders is we can express them as a fraction in terms of whatever our divisor is. So this is actually 64 pieces that would have been divided by x minus 2. So we can actually place that at the very end as being plus 64 divided by x minus 2. So that would be my entire, answer, both the part that went in, we could say evenly, and the leftover remainder bit. So we get 3x cubed plus 6x squared plus 16x plus 31 plus 64 over x minus 2. So this was an example of a long division, one where one of the coefficients was actually a 0. So in order to make sure that this kind of stair-step approach of what goes on during a long division was fairly smooth in terms of not having to worry about where things line up, then we end up getting this result in the end that if we were to take that, multiply it all back out by x minus 2, we should get the original 3x to the 4 plus 4x squared minus x plus 2. Not going to do that right now, but if you'd like to do it on your own and just make sure that things seem to all line up at the end, that's the way that we could go about checking it. So hopefully you found that one helpful. If you did, like, subscribe. It's good to be back. And as always, take care, folks.